Okay, guys, good morning. Welcome back. Week 4, day 1. I hope that you rested enough on this week that we had as holiday vacations, okay? So what are we going to see today? We're going to see the third method for solving systems. We saw already solving systems by graphing, okay? Where if the two lines intersected in one single point, then that was one solution. If they were exactly the same line, graph one on top of the other, there was infinitely many solutions. And if the lines were parallel, then it was no solution. Then we saw the second method that was solving systems using substitution, where we had to have one equation with one variable completely unknown and positive on one side, and that we substituted inside the second equation or the other equation in order to leave the equation in terms of one variable and then solve that variable. Well, today we're using another method, another form. And in this particular case, we do not care that one variable is completely alone in one side. We actually need to have both equations, both variables in both equations on the same side. It could be both on the right side, it could be both on the left side. It doesn't matter as long as they're both on the same side. And one term underneath the other term that has the same variable, okay? Just like when we were adding and subtracting polynomials on 7th grade. And the other thing that we need to have in this case is one of the variables with exactly the same coefficient, but with different signs, okay? So it doesn't matter what variable, but they have to have exactly the same coefficient, okay? But with different signs. Why? Because we want to cancel them out. We want to eliminate one of those variables in order to have a one-step equation. So let's see the first exercise. In our first exercise, we got 3x minus 5y equals to 9 and 2x plus y equals to 3. Still, the three same types of solutions are going to be applied in here. One solution, if we have one value of x and one value of y, no solution when we have something that's not real, like 0 equals to 3, and infinitely many solutions when we have exactly one side equal to the other, like 0 equals to 0, okay? In this case, first equation, we got 3x minus 5y equals to 9 and 2x plus y equals to 3. I'm going to check variable by variable in each equation. And I'm going to see if I already have one term that is exactly the same as the other, but with different signs. So we got 3x and 2x. Both are positive, both have different coefficients. Negative 5y and y. Different signs, but also different coefficients. However, since they have different signs, I know that I can use those to eliminate that variable. What do I have to do? I just need to multiply one of the equations by a number in order for them to have exactly the same number with different signs. Sometimes you're going to multiply both equations by an LCM, by a number, so you can find the LCM. In this case, we got negative 5y and positive 5y. So I'm going to multiply this second equation by what number in order for them to have the same coefficient but different signs? Have to have the same number. This is negative 5, this is positive 1. By what number should I multiply the whole equation to make this the same as this, but different sign? By 5. Why by 5? Because if this is negative 5, I need this to be positive 5 in order for me to cancel them out. So what am I going to do? I'm going to copy the first equation because I'm multiplying nothing to that equation. So 3x minus 5y equals to 9. And I'm going to simplify and multiply with the distributive property, the other one. 2x times 5.
10x.
10x. Y times 5.
Positive 5y.
Positive 5y equals to 3 times 5.
15.
15. As you can see, I have exactly the same variable with exactly the same coefficient, but with different signs. So I'm going to cancel that out. I'm crossing a line underneath this, and I'm going to add and subtract the rest. This is 0, so I cross it out. 3x plus 10x.
13x.
13x equals 2. 9 plus 15.
24.
24. And you see, I told you, we have one step equation. So I need to leave the x completely unknown. So the 13 goes to the other side.
Dividing.
Dividing. And we are left with x is equal to 24 over 13. Can I simplify 24 over 13? Simplify that?
No.
No.
No, so I leave it like that. That's my value of x. Now that value that I found, I'm going to substitute it inside of any of the two equations and solve for the variable y. In this case, I'm going to use the second one because the variable y has no coefficient but invisible one. So it's going to be easier. So I'm going to say 2x, but instead of x, 24 over 13 plus y equals to 3. I multiply this, 2 times 24, that's 48 over 13 plus y equals to 3. I need to leave the y completely alone in one side, so this 24 goes to the other side, subtracting. So I'm left with y is equal to 3 minus 48 over 13. How do I simplify this? How do I solve that? How do I solve this integral minus this fraction?
Dividing all by 13.
Dividing all by 13, like multiplying actually, so we can eliminate the 13, not dividing. Multiplying by 13, or another form, happy face.
The cross multiplication method.
The happy face method, okay? So I'm gonna multiply this like that. And I'm gonna have y is equal to 3 times 13 3 times 13
39.
39.
39. 1 times negative 48
48.
negative 48, because it's times negative 48, remember? Over 1 times 13
13.
Now let's simplify. How much is 39 minus 48?
That is 9.
Negative 9 over 13. Can I simplify that? Can I simplify it? All right, I cannot. 9 over 13 cannot be simplified. So how many solutions do I have?
One solution.
One solution. And what is the solution for this exercise?
24 over 13, comma negative 9 over 13.
Exactly. So that is my final answer. 24 over 13, comma negative 9 over 13. One solution only. Questions about this? No? We clear? Okay then. Now I'm going to separate this a little bit so we can know that this is my second exercise. Okay. So let's go for the second exercise. There's no question. No, we're clear. Okay. So I'm going to move this a little bit to this side. And we're going to say we got 3x minus 2y equals to -3. And we have 6y equals to 9x plus 9. And I just told you that we need to have both variables on the same side. Okay, or at least having the variables in the same side in both equations. Okay, so in this case, we got 3x minus 2y, both variables on the left. And on the second equation, we got 6y equals to 9x plus 9, one equation in each side. So it is easier for me to leave both variables on the left by passing this positive, negative. Okay, so that's easier. So I'm going to copy the first equation just as it is. 3x minus 2y equals to -3. And I'm going to pass this 9 to the other side and placing it underneath its like term. So -9x plus 6y, because the 6y is already on the left, equals to +9. Let's look at the equations. We got 3x minus 2y equals to -3 and -9x plus 6y equals to 9. Let's compare the terms 3x and -9x. Different signs as we needed, but different coefficient. We need them to have the same coefficient. The other one is -2y and +6y. Different signs, but also different coefficients. And I need them to have different signs, but the same coefficient. Okay, so in this case, both of them have different signs. So it doesn't matter which one I multiply or which variable I eliminate, but I need to eliminate one. So pick a variable that you want to eliminate. Would you rather eliminate the x or would you rather eliminate the y? Since both of them have different signs. Which one would you like to eliminate?
The x.
The x, okay, you want to eliminate the x. So both of them have to have the same coefficient, but different sign. We got 3x and -9. Should we multiply only one equation or both equations? In that case, by what number or by what numbers should I multiply it in order to have the same coefficient? Remember, we're eliminating the x. So I need to multiply either one equation or both equations in order to have the same coefficient. So which one, or is it both? And by what number? Which one and by what number?
I think that the first one is and multiplied by 3.
Okay, very good. Let's see. Let's see if it is the first one multiplied by 3. So we got 3 times 3x.
9x.
9x.
9x. -2y times 3.
-6y.
-6y. Equals to -3 times 3.
-9.
-9. Remember, we multiply the whole equation. Okay, and the second one, we got -9x plus 6y equals to 9. So we're canceled this one positive, one negative, exactly the same coefficient. So I cancel them out. And then we add or subtract the rest, okay, in order to solve it and to simplify it. And I got -6y plus 6y. Again, the same coefficient, but different sign. So I cancel them out. And we got equals -9 and 9. The same number, but with different signs. So I cancel that out as well. But if I canceled everything on both sides and the only thing that I didn't cancel is the equal sign, what should I place? If I cancel everything on the left, what am I left with?
0.
0.
0. And if I cancel this on the right as well, what am I left with?
0.
No.
0. So 0 is equal to 0. So how many solutions do I have?
Infinitely many solutions.
Infinitely many solutions. Very good. And that's the second form of answer that we can have. If by any chance, instead of getting 0 equals to 0, you got 0 equals to, I don't know, let's say 18. Is 0 equal to 18?
No.
No. So if that would have been the case, what would have been my answer?
Easy, no solution.
No solution. Very good. But since we got something that is true, like 0 equals to 0, then my answer is infinitely many solutions. Do we have any questions so far? No? Easy peasy, breezy, lemon squeezy, right? Okay, let's go with our very last exercise for today. So we got negative 4x minus 3y equals to 15. And we got 3x minus 2y equals to negative 8. Let's look again the terms and let's compare them. Remember, we need to have the same coefficient, but with different signs. It doesn't matter which variable because we need to eliminate one variable. So we got 4x negative and positive 3x. Different signs as we needed, but different coefficients. We need the same coefficient. And then we got negative 3y and negative 2y. Same signs, we need different, but also different coefficients. We need it the same. So which variable do you think is easier to eliminate? The x or the y?
The y, I think.
The y? Okay, one more time. The y has exactly the same signs and the x has already different signs. If we eliminate the y, as Genesis is telling us, which we definitely can do it, it means that one of the two equations has to be multiplied by a negative number. Why? Because I need one negative and one positive, or the other way around, one positive and one negative. So one of those is going to be multiplied by a negative sign, and that's okay. But one is 3 and the other one is 2. We need them to have exactly the same number. So let's begin. Which equation are we going to multiply by negative? The first one or the second one? So we can make it one negative, one positive. Which one are we multiplying by negative? So we can make it positive. The first one or the second one? And this is you were the one that said that you wanted to eliminate the y. So which one? First one or second one, am I going to make it positive sign?
Second one.
The second one. Okay, that's fine. So we're going to multiply the second one by a negative number. So this negative on the y becomes a positive. Okay, now let's check out by what number should I multiply 2 so it has the same coefficient as in the first equation. It's hard, right? To find a number to multiply the 2 to make it a 3. So what are we going to do? We're going to multiply both equations by another number so we can have the same LCM, least common multiple. Sometimes it's hard to think of the number, okay? In this case, it's easy. A number that's common in the multiplication table of 3 and of 2. In this case, it is easy. Sometimes it will not be easy. So what are you going to do? You're going to use prime factorization. So we got 3 and we got 2. We're going to prime factorize this so we can find the LCM. So what is the smallest prime number that can divide either of them? 2. That's the smallest prime number. 2 divided by 2, 1. 3 divided by 2, I cannot do it because it won't give me a whole number. Now, what's the next prime number that I can use to divide any of those? 3. This is 1 already, and 3 divided by 3, 1. And that's what I needed, to have them all in ones. So now I'm going to multiply this. How much is 2 times 3?
6.
6. So this number in here with the y has to be a 6, one negative, one positive. So this -3, by what should I multiply it to make it a -6? So 3, by how much I multiply it to make it a 6?
2.
By 2. And this 2, by how much should I multiply it to make it 6?
By 3.
By 3. Very good. Now we multiply. -4x times 2.
-8x.
-8x. -3y times 2.
-6y.
-6y.
-6y equals to 5 times 2.
10.
10.
Let's go with the second one. 3x times -3.
-9x.
-9x.
-9x. -2y times -3.
Positive
Positive 6y.
Positive 6y equals to -8 times -3.
positive
Positive 20.
Positive 24. Very good. And I cross it over the little line. And now I'm starting to add and subtract. Now remember, these are different signs, so I can cancel them out. And I'm left with -8x minus 9x.
positive x.
No, -8x minus 9x.
-17x.
-17x. Very good, because same signs I add and I keep the sign. Equals to 10 plus 24.
34.
34. Very good. Now I'm left with one step equation. I pass this -17 to the other side, dividing in order to leave the x alone. And I'm left with x is equal to 34 over -17. Can I simplify that?
Yes.
How much is it then?
2.
-2.
-2. Very good. Don't forget the sign. Now this value, I'm going to substitute it in either of these two equations. Doesn't matter which one. Which one would you like me to substitute it in? In the first one or in the second one? It doesn't matter.
The second one.
In the second one. Okay, so I'm going to have 3 instead of x, the -2 minus 2y is equal to -8. You see, I'm doing it in the original. 3 times -6. I mean, 3 times -2.
-6.
-6 minus 2y is equal to -8. Now remember, I need to have the variable completely alone and positive on one side. So I'm passing this one to this side to make it positive, just because I want to. And the -8 goes to this side positive, also because I want to have the variable positive. So I'm going to have -6 plus 8 is equal to 2y. -6 plus 8,
+2.
+2 is equal to 2y. The 2 is multiplying, passes dividing, and I'm left with 2 over 2 is equal to y. Can I simplify that?
Yes.
Yes.
How much is it?
1.
Very good. How many solutions do I have then?
1 solution.
And what is my solution?
-2, 1.
-2 of the x, 1 of the y. And that is my solution. If I request you to check the solution, you substitute these two values inside of both equations, and you have to get exactly the same answer. 5 equals to 5, and -8 equals to -8. You have to have something that is true. If not, you made a mistake somewhere, okay? Either in the check-in, in the evaluation, or in the procedure. And that is our topic for today. Let's place today's topic's name. What is the topic's name today? We solved equations using what? Systems, sorry. We solved systems using what? What method did we use? We saw already solving systems by graphing, solving systems using substitution because we substituted. And in this case, what did we do to one variable? What did we do? Daniel?
Use
We multiply.
elimination.
You think what, Josue?
I guess elimination.
Very good. We eliminated. So using elimination because we eliminated, okay, one variable. So that's the third method of solving a system. Do you guys have any question whatsoever about the topic today? No questions? We good? We clear? We're moving this a little bit so you can have it like that, like that. No questions. Okay, then this is the topic for today.